Let's look at how to calculate the determinant of a 3 by 3 matrix. So let's look at an example. I'm going to take a matrix and 1, 2, 1. To calculate the determinant of a 3 by 3 matrix, we need to break it down into smaller matrices. To do this, we're going to use the cofactor method. So the cofactor method is you can choose any row or column. For simplicity's sake, we're going to take the first row, and you see the items is 1, 2, and 5 in this row. So let's look at the first item, which is 3. If we look at the first item, which is 1, we can write down positive 1, and then we can write the cofactor of 1. So to get the cofactor of this row, we basically take all the items that's not part of this row or the column which is part of this element that we're looking at. So the remaining items is 3, 5, 2, 1. So let's 3, 5, 2, 1. Then we take the next item, which is 2, but now we subtract the 2, and we'll get to the signs and how we determine the signs shortly. And then we look at the cofactor of 2, which would be then all the items that's not in row 1 or column 2, which would be 2, 5, 1, 1. So 2, 5, 1, 1, and the last element is 5. And we get the cofactor of 5, which is all the elements that's not in this row or column 3, which is 2, 3, 1, 2. And then we can go ahead and do the determinant of a 2 by 2 matrix, which we already know. So we always take the top left and multiply it by the bottom right. So it's going to be the 1, keep it in front, and then 3 times 1, and we subtract 2 times 5. And the same for the second item, we take 2 times 1, and we subtract 1 multiplied by 5. And then the last item is 5, and we do 2 times 2, and we subtract 1 times 3. So I've taken elements that's got all positive signs just to make it clear when to use negative and positives. You'll see in this case the only item that changes is the second item. So how do we determine the signs to use? We'll continue with this first, so let's just complete this before we get to that. So this is going to be 3 minus 10, 2 minus 5, and 4 minus 3. So it's going to be 3 minus 10, which is minus 7, times 1 is minus 7. 2 minus 5 is minus 3, times minus 3 is plus 6. And 4 minus 3 is 1, 1 times 5 is 5. So the determinant of this matrix is going to be minus 7 minus 1. So it's going to be 4. So you'll see the answer to the determinant of a matrix is always a scalar value. In this case, it's 4. So if we look at the signs, the first item was positive, next one is negative, and the following one was positive. If we determine the signs here, that's going to be positive, negative, and positive. The same will go for row 1. It's going to be positive, negative, 1, positive, and then we can continue this pattern. So if we, for instance, take the second row, we can take any row, any column. The second column is going to be minus 2, plus 3, minus 2. The last row is going to be plus 1, minus 2, plus 1. So you'll see you can use this shortcut to determine the matrix. Let's just show you an example of where we do this. So let's take the same matrix 1, 2, 5, 2, 3, 5, 1, 2, 1. So let's take the second column this time. So I'm going to take this column. And the first item is 2, and you'll see according to this design help that we've got here, diagram is going to be minus 2 multiplied by the cofactor of 2. So remember, we take this row and column, and what's remaining is the cofactor, which is 2, 5, 1, 1. So it's going to be 2, 5, 1, 1. And the next one is going to be positive 3. And the cofactor is all elements that's not in this row or column, which is 1, 5, 1, 1. 1, 5, 1, 1. And the last element is minus 2, in this case, that 2 over there. And the cofactor is the elements that's not part of this row and column, which is 1, 2, 5, 5. Sorry, 1, 5, 2, 5. Okay, let's go ahead and do the cofactor. So it's going to be 2 times 1 minus 1 times 5, so it's going to be minus 5. And let's just write the answer here. 1 times 1 is 1. 1 times 5 is minus 5. Remember, we'll subtract the diagonal from left to top right. And the last one is going to be 1 times 5, which is 5, minus 2 times 5, which is 10. Okay, so let's just do the shorthand here. It's going to be 2 minus 5, which is minus 3. 1 minus 4 is minus 4. 5 minus 10 is minus 5. So if we do the answer here, let's just do that here. It's going to be minus 2 times minus 3, which is 6. 3 times minus 4 is minus 12. And minus 2 times minus 5 is plus 10. And the answer for this line would be 6 minus 12 is minus 6, plus 10 is 4. So you can see we get the same answer if we take the first row or the second column to determine this matrix.